Today I'm going to talk about the cause of electromagnetic acceleration. This is one of the biggest problems in physics that's not explained by the standard model, but it's fairly straightforward to explain. And it's really sad that physicists don't include this in their teaching, because they say that we have electromagnetic forces. There are plenty of equations to describe what happens in response to those forces. But it doesn't say how objects actually move, what causes objects to move and how. They say that there's a gauge boson that magically tells objects how to move, and then they somehow move. And I just did a video on virtual photons that actually says that no, virtual photons aren't the gauge boson on electromagnetic theory. You can see that when I'll link it below. So we can start by understanding that particles and objects don't have jetpacks. They don't have a jetpack strapped on their back with a computer processor telling the jets how to operate, how much to propel, and they don't carry a bunch of propellant. They don't lose mass. So we're not looking, this isn't rocket science. We're not looking at particles and objects having a propellant that they expel in order so they can move forward. That's not how this works. And we know that because particles in orbit, such as an electron around hydrogen, don't lose mass. They don't lose energy. If they did, they'd spiral in. But they don't. And also planets don't spiral in, because they're not losing mass. They're not ejecting mass continuously in order to stay in orbit. If they did, they'd very rapidly lose mass and then fall into the sun, in the case of Earth. So we know there's something else going on. And the only thing that could be going on is objects are being pushed. And the only thing that can provide the pushing is the quantum field. So we have pressure coming from the quantum field, and if pressure changes somehow due to electromagnetic interactions, that causes bodies to accelerate. So given that is our only possible solution, it's fairly straightforward to figure out how this happens. So what we have is a situation between like charges where, if we consider the normal Faraday field lines, the lines are in a repulsive configuration because they can't line up with positive charge to positive charge, or negative charge to negative charge in the other example. So they deflect away. And we can readily imagine that this increases the pressure pushing the two charges apart versus a normal configuration, say there's no charge. And while there's still pressure from the outside pushing them. And then if we consider the opposite situation where we have opposite charges, we get the Faraday field lines in the attractive configuration. And this actually causes a reduction in pressure pushing the objects apart, which we can see if we look at what happens over time. Over time, the number of quantum fluctuations between two particles decrease. And so the force pushing them together has opportunities to push the objects together as the quantum fluctuations annihilate and disappear, and before they get replaced by newer quantum fluctuations. So there's a process by which they're constantly being eliminated between opposite charges. And this is true for opposite electric charges as well as like and opposite north and south poles of magnetic or of magnets. So the magnetic forces do the same thing. You get a repulsive force between like poles and an attractive force between opposite poles because of an increase in pressure between like poles and a decrease in pressure between opposite poles. So this gives us a phenomenon where pressure differentials are the cause of all acceleration. And so to simplify picture you can have two plates that are charged. If they're like charged, they get pushed apart because the force pushing them apart is greater than the force pushing them together. And if they're opposite charges, they push together because the force pushing them apart is less than the force pushing them together. And if you've heard anything about the Casimir effect from watching one of my other videos or just your study of science, you realize that, hey, this is the Casimir effect. And that's one of the things about the Casimir effect, is the Casimir effect was the only force in the standard model that actually explains the physical cause of acceleration. It's the only one. Electromagnetic theory doesn't explain it. Gravitation doesn't explain it. The strong force doesn't explain it. The weak force doesn't explain the acceleration. The only force interaction that explains it is the Casimir effect. And the Casimir effect explains it as van der Waals forces causing pressure. And the pressure between two plates is reduced in the Casimir effect because there are fewer quantum fluctuations in between the plates, which lowers the pressure pushing them apart, causing them to be pushed together by the forces coming from outside. Now the problem, which I'll get back to, is the van der Waals forces in the Casimir effect don't obey the inverse square law. And the pressure force responsible for acceleration due to electromagnetic forces must obey the inverse square law. So assuming that it's a quantum field that's pushing on objects and pushing them together or allowing them to be pushed apart, this pressure has to obey the inverse square law. So we are dealing not with the question of can someone derive an inverse square law obeying pressure from quantum field interactions, but we have to derive it because we really don't have a choice. There's no other thing in space that could be providing the push responsible for the acceleration. So it has to arise from a quantum field in some way. So I'll propose a way to do that. But first I want to also mention that between electrically neutral objects, like two planets or a star and a planet, you also get a force differential, a pressure differential, due to a shadowing effect. That this object blocks pressure coming to this object, and this object blocks pressure coming to this object. And this leads to a fact that's sometimes called shadow gravity. It was first described by Nicolas Fatio de Duyer in the 1690s. He was a contemporary of Newton's and actually spent some time in England with Newton. And he recognized that this might be the way to explain gravity, that if you have corpuscles in space pushing on objects, but that the objects block each other from this pressure, that they'd be pushed together, and this would explain gravity. And mathematically it works out fine. The question back in the day was that people treated the ether like it was a gas, and they felt that the gas would heat the objects, causing them to vaporize. And so this was always the objection to the Fatio theory, which was later popularized by Lesage in France, who didn't give Fatio credit, although he knew about it, but he may have originally came up with the idea independently. We're really not sure at this point. But anyway, in this electromagnetic acceleration cause, there would be acceleration between electrically neutral objects. And because of the Casimir effect, we know that it exists, and we know that the two plates aren't vaporized in the process. So the heating argument is nonsense. Objects aren't destroyed by heat. The quantum field doesn't interact with objects in a way that causes them to be destroyed like that. So we can explain gravity and gravitational acceleration as a phenomena strictly due to electromagnetic acceleration. So gravity is an electromagnetic phenomenon. And so is general relativity, and that's because the origin of spatial dimensions and time, the clock rates, is an electromagnetic phenomenon that emerges from quantum field theory. I'll talk about that in another video. So the remaining question is, well, how do we get this inverse square law obeying pressure from quantum fluctuation interactions? And if we think about the normal interactions between an electron and positron, if we have two electrons together here and two positrons here, they'll repel, of course, which would, if that was the only interaction, would lead to an inverse square law force. But if you flip them together, they're attracted, and so, oops, it doesn't work. You end up with, in the case of two quantum fluctuations, what I call cross annihilation. And this prevents the normal van der Waals forces between two electron-positron quantum fluctuations to have a long range. It leads to the typical short-range van der Waals forces. But what happens when you consider an electron-positron pair and a proton-antiproton pair in the quantum field is different, because we know from hydrogen that an electron doesn't merely fall into a proton due to electromagnetic attraction. There's some type of repulsion that prevents it. There's some type of quantum tunneling that's needed for the electron to get inside the proton and form a neutron. And so there's continuous repulsion going on. So in one place, if we have protons with like charges together, like electrical charges together, they would repel. But if they have opposite charges together, they still repel. So there's a constant state of repulsion between the electron-positron quantum fluctuations and proton-antiproton quantum fluctuations. And this is what causes a pressure that obeys the inverse square law rules. And now I haven't proven this mathematically, even though it's intuitively obvious. And if you're a mathematician who has ideas how to solve this problem and you want to do a paper with me, get in touch and we'll do a paper. Otherwise, I'll get to it when I get to it, when I'm done doing other papers that I'm working on. Anyway, so the explanation for how electromagnetic acceleration works is quite simple. It's based on quantum field pressure that's due to a van der Waals force that develops within the quantum field that obeys the inverse square law. And this pushes objects together or allows them to be pushed apart. And it also explains gravity as a purely electromagnetic force, normal Newtonian gravity. The relativistic effects are somewhat different, and I'll, like I said, talk about them in another video. So if you like my video, please like, subscribe if you'd like to see more, share it with your physicist friends, and if you want to learn more, I have 3 books on quantum field theory and one that's also on particle theory from a quantum field theory perspective, and that they're available for sale. And I'm retired and working as an independent researcher, so if you buy one of my books, that helps support me, and I appreciate that. And I also have a Patreon account if you'd like to go that route. So thanks for watching.